Our next lesson is 10.4, Inscribed Angles. You'll notice we're skipping lesson 10.3. I also would like you to have a calculator for this video lesson, just so that you can enter the same things I do and make sure we can get the same end result. A few definitions for inscribed angles. An inscribed angle is formed by two chords. And remember, chords are just two segments that have endpoints on the circle. Or you could have a chord and a tangent, with the vertex for either setup being on the circle itself. So this is different from central angles that we talked about in 10.1. Different than central angles. A central angle had the exact same measure of the arc on the circle that it intercepted, but the measure of an inscribed angle is different. So the measure of an inscribed angle is going to be 1/2 the measure of its intercepted arc. So take a look at the three examples, the three diagrams down below. We have A, B, C as an angle. So from A over to B and down to C, that's called an inscribed angle. From A in the middle to B over to C, also an inscribed angle. And then A, B, C. So all three of those are examples of inscribed angles. So you'll notice that they all intercept an arc. And that's arc AC here, arc AC over here, and then arc AC on that last example. By definition, an angle measure is always going to be half of the value of the intercepted arc. So put an arc symbol above, and that'll help you remember which part of the picture we're looking at. So that's when it's formed by two chords. Down below, we'll look at a different kind of setup, but the formula will stay the same. Notice on this picture, there's a line that's on the outside that touches the circle at just one point. So now if the angle is formed by a tangent and a chord, it's going to still be 1/2 the measure of the intercepted arc. So take a look at the angle for ABD. Go to A to B, which is on the circle, and then over here to D. That angle measure is going to be 1/2 the measure of its intercepted arc, and that would be minor arc BD. So the measure that's on that circle. So now this time, the angle actually touches that part of the arc, but it's still a 1/2 rule. All right, let's take a look at a variety of examples that apply this inscribed angle definition. What is the relationship between arc AB on the picture on the right and angle ACB? So the angle is always half of the intercepted arc. So this angle over here on the bottom right is half of that intercepted arc. But when we flip-flop it, if I want to know the arc measure, that's always going to be double whatever the inscribed angle is. So really today, your game plan is going to be to multiply something by 1/2 or to multiply something by 2. We just have to decide which is which. So let's look at example 1 down below. Given circle P with inscribed angle S, let's go ahead and underline inscribed angle. If the measure of arc RT is 47, what is the measure of angle S? Well, if we take a look at kind of our template up above, we know that the measure of angle S is an angle rule. And angles are always half of their intercepted arcs. So if I have angle on the left and I have arc on the right, if I know the arc, I'm just going to cut it in half. Pretty easy. We know that RT, that measure of the arc over here, is only 47. If we take half of 47, or 47 divided by 2, that would give you 23.5, and our label is degrees. The measure of angle S, which is an inscribed angle, is 23.5 degrees. Flipping it over to the next page, we have example 2. 2a asks if the measure of arc DG is 45.6, what are the measures of angles E and F? Well, if we look at this setup, we have an arc right here, DG. Over on the right, that's just that measure on the circle. It's 46.5 degrees, 45.6 degrees. The measure of angle E, if we connect from kind of the chord to the chord, so D up to E over to G, angle E is an inscribed angle. And the measure of angle E, because it's an angle, is going to simply be 1/2 the intercepted arc. So the measure of DG. That would be your arc measure. Well, half of 45.6, you could also just type in 45.6 divided by 2. Half of 45.6 is 22.8 degrees. So now take a look at the other angle they want us to find. They also want us to find angle F. So if I look at the chords that create angle F for that inscribed angle, I'm going to go G up to F over to D. So take a look that that intercepts the same arc as well. So now the measure of angle F is also going to be 1/2 the measure of arc DG. It's the same thing. So again, half of 45.6 is 22.8 degrees. Both of the inscribed angles are the same. So it says angles that share an intercepted arc are congruent. They would have the same measure. Which is kind of nice. You get 2 answers for 1 on that picture. Example 2b has an interesting component to it. If arc RT is a semicircle, what is the measure of angle RST? So let's underline semicircle. The rule for a semicircle is it always has the same measure. A semicircle, because it's halfway around, will always equal 180 degrees for the arc. And you'll know you have a semicircle because it's always when one of your sides for your inscribed angle is a diameter. So always with a diameter on these pictures. That's something that you can always conclude to be true. All right, so because of that, we want to find the measure of angle RST. So if we look at the picture, the measure of angle RST goes from R over to S on the left and then down to T. It's that angle measure right here. Because that's an angle, by definition, I want brackets around that, sorry. By definition, it's always half the measure of the intercepted arc, RT. So write that in there, and then underneath it, please write arc. If the measure of that semicircle on the arc is 180, then we're just going to take half of 180. Or multiply, or 180 divided by 2, either way. You should get 90 degrees for the measure of angle S, which would make that a right triangle inside that circle. Now the last picture for example 2 is going to have us do quite a few things. So if you have different colors, now would be a great time to use those. If not, just kind of take your time and watch how we go through this question. It says if the measure of arc ABC is 184 degrees and the measure of arc BCD is a whopping 242, what are the measures of the angles of the quadrilateral ABCD? So we're still again comparing angles with arcs. Taking a look at our picture, it says if the measure of angle if the measure of arc ABC is 184, that means on the picture we're going from A, B, all the way down to C. That's 184 degrees. But then arc BCD is 242, so that's even bigger. So from B around to C and all the way over to D over here, that's 242 degrees. What are the measures of those angles inside quadrilateral ABCD? Well, let's take a look at how these two given arcs can help us. If the measure of arc ABC is 184, I recognize that D up to A and D down to C would be the angle that intercepts that arc. So the measure of angle ADC, or angle D, is an inscribed angle. We could say that the measure then of angle D, which again is an angle, should by definition be 1/2 the measure of its intercepted arc, which in this case is the measure of arc ABC. Put that arc symbol up above, just kind of like a little curve, and then write arc underneath it. Well, if ABC is 184, take half of 184. If you enter that in on your calculator, the measure of angle D should equal 92 degrees. One down, we have 3 more to go. Now the other arc we were given is arc BCD. So from B to C all the way around to D. Inside that picture, recognize that angle A would intercept that arc on the right and then over here on the left. So that angle would be half the intercepted arc. Therefore, the measure of angle A, which again is an angle, the more you practice writing out what these parts are, the easier it'll be to remember the definition. Now, I've kept the angle and the arc in green. Oh well. So the measure of angle A, that inscribed angle, is going to be half of the measure of arc BCD. Measure BCD, put an arc up and over, and then write arc underneath. Now, if BCD is 242 degrees, that means the angle is half of that, which would be 121 degrees. 2 down, 2 to go. All right, what else could we do here? I recognize that, what do we know? What do we know here? Well, if we take a look at that green arc, the 242, I can see that the part that's left over is from D to B right here. So if I can find the measure of arc DB, that should help us find angle C on the opposite side. Let's see, now all the way around the circle we know is 360 degrees. If we subtract the arc in green, that BCD, get a little minus sign in there, subtract 242, that would give us the measure of arc BC to equal 118 degrees. So that's this arc up here in orange. And then the measure of angle C at the bottom would be half of that. So measure of angle C at the bottom, and again, please write angle, is going to be 1/2 that measure of arc DB. That's a D, not a P. It's not peanut butter. DB. There we go. And that's arc. Half of 118 is 59 degrees. We have 3 of the 4 angles inside that quadrilateral. Once you know 3 of them, remembering what we know about quadrilaterals, we talked about it last week. All 4 angles should add up to 360 degrees. The angle that we're missing is angle B. Therefore, to get the measure of angle B, we can take 360, just minus the other angles that we know. So minus 92, minus 121, and minus 59. Please enter that all into your calculator. What would be the measure of angle D? Excuse me, B. Wow, the measure of angle B. Sorry. We should get exactly 88 degrees. And using those arcs was super helpful to get us started, but then we just recognized that all the angles in a quadrilateral add up to 360. All right, moving right along, I think we have just one more example. Example 3 will be the last example in this video. It says, if the measure of arc RST is 164, what is the measure of angle RVT? Well, let's first start with identifying our arc measure. From R to S to T, let's go all the way around like so. That's 164 degrees. It says, what is the measure of angle RVT? So if I go from R over to V up to T, that's our inscribed angle. So by definition, the measure of an arc, or excuse me, the measure of an angle, let's write angle down below, because it's going to flip for the next example, always is equal to half the measure of the intercepted arc. So half of measure arc RST. Okay, so there's our arc. And now we just plug it in. Pretty simple. Half of 164 degrees is only 82. Done. Super easy. But in the next example, we flip-flop the idea. It says, if the measure of angle SPU is 79, what is the measure of angle arc STU? So now we know the angle first, from S down to P and up over to U. That's an inscribed angle that equals 79 degrees. And we're asked to use that information to find the measure of arc STU, so the arc that the angle intercepts. Well, the measure of an arc is the opposite operation. Instead of multiplying the angle by 1/2, we actually double the angle. And we had that written in our notes from the first page. We just haven't done an example like it yet. But here we go. Twice the measure of angle SPU. And that's an angle measure. If that angle is 79 degrees, we double it to find the measure of the arc it intercepts. And that would give us 158 degrees for the measure of arc STU. We're going to stop here and then do a little practice work for 10.4, day 1.